All right, hey guys. So today I'm going to be talking about a problem that I think a bunch of people are solving, and kind of a unique approach that we're taking, and kind of spill some alpha a little bit how we're solving it. We haven't solved it yet, but we're playing around, and I want to show you guys how we're doing that. A bit about me. My name's Matt. I work at Proof of Play. I'm a steganography nerd, hardcore gamer. Also, this is my dog Izzy, and an engineer by trade. And so steganography-wise, some of the coolest things I worked on, I used to work at Riot Games. We worked on this cool thing where in esports broadcasts, we wanted to sync live stats with them. And we had a video stream that was going through, and we had like a JavaScript console with the events. And essentially we hid kind of like hidden sounds inside the broadcast using steganography, and then decoded that with fast Fourier transform. Super, super cool and fun. Didn't make it to production, but we got it working. And so we're able to sync like that, so super cool. Brief background about Proof of Play. We make a game called Pirate Nation, hence the pirate here. We build on-chain games primarily, but in service of that, we make on-chain gaming infrastructure. So, solving two problems at once because we have to, like everyone else here. Bit about Pirate Nation, fully on-chain RPG. Game style, similar to kind of like a mix between Clash of Clans, Farmville, more lately a little bit of island building action, a bit more swashbuckling. Been live since basically the FTX crash. That's when we minted. It was a very stressful time. Been on 3 networks, currently on 2. So right now we have like expensive NFTs on ETH for liquidity. So people playing the trading game inside the game can essentially have more visibility. And then the gameplay actions right now are on Nova. Super fast, been really, really happy with it. Our approach to building is basically like twofold right now. We're doing a lot of work with our community. So as a recent addition, we had our community kind of have a look at what our roadmap was, and we posed them some questions, and they decided that island building was going to be the thing that they wanted to get in. So we moved that up in our roadmap. And then on an underlying level, obviously we've been live for quite a while. We are following a lot of what's going on in the autonomous world space. We're redesigning a lot of our contracts to be autonomous worlds compatible. So while we didn't launch like that, we've implemented an ECS. It's kind of like same signature as MUD, so that people building with MUD can use our tools as we open source them. So kind of like trying to get into that ecosystem, make sure we're kind of plug and play. Today I'm going to be talking about some alpha that we're working on, which is a PvP protocol. It is like super new, it's not finished, but I wanted to get it to this audience in particular because I feel like people here are solving super hard problems. And so talking about it, we can share the problems together and come up with solutions. And so here's a little bit of a demo of kind of our old combat system versus our one that we're prototyping. Different style game a little bit, and huge caveat here, this is not final. We are playtesting this internally. We have like a iteration loop where it needs to be fun. These graphics are not real, like they're just placeholders. But the main difference between the two of these is this one's transaction based. And so every action you do takes a couple of seconds, comes back with a transaction, goes to the L2 chain. This one over here though, this is using PvP protocol. And so this is actually kind of way faster. We're talking like this one is seconds, this one's is tens of milliseconds. So massive, massive jump in performance. And yeah, that's a bit about it. Now what's under the hood for that? Let's have a look. So firstly, every action is deterministic in this model. All the blockchain people here are pretty familiar with determinism, how it works. But it's actually not that rare in big games as well. At Riot, we converted all of League to be deterministic for a feature called Chrono Break. So I'm not sure how many people of you guys follow esports, but with Chrono Break, we're able to replay a game from the start of the game exactly as it was outlaid. So really useful if you're in a big event and the Wi-Fi cuts out. All of a sudden, you can restart the game, do it before anything unfair was there. So super, super useful. So here's a bit of how it works. Going to the nuts and bolts of it. The design of PvP protocol has kind of two main applicability things. Firstly, decentralized validation. So right now, you submit a move in that example before, and there's 2 ways you can do it. You can have other game clients sign the moves. So they basically look at the previous states, calculate the difference between them, and come up with a result and send it back to you signed. Or you can, instead of the peer-to-peer model, you can run validators yourself or servers or whichever way you want. So super flexible with how it works. And then PvP protocol is a little bit misleading in terms of the name because we plan on using it for a lot more things than that. Two examples that we're thinking about right now, island placing. So right now when you're placing objects on an island, we do a very naive check on blockchain. We basically check like a box, and is the box of this item the same as the box of this item? Do they collide? Yes or no? We can't really do much more because of gas limits. Our design decision was portability, so we're not doing anything like increasing the gas limits on the blockchain. We want to be able to use any chain. And so for that, we can use this approach to do the validation. And for checking something on an island with hundreds of objects on it, it makes sense to do that, especially when we're checking, we're based in the Caribbean. So we have a giant palm tree. If you look at a palm tree, the base of the palm tree is super small. But as it goes up and around, it kind of has this massive overhang. And so you do need to kind of compute every single element of where it could go using collision detection there. Another application we've been thinking about is for multiplayer. So two pirates running around an island. Essentially with this, because of the low latency, we're talking 10 milliseconds kind of here, you can have the peers validate each other running around the island together. So they can get the multiplayer seeing each other, and we can later validate it on chain as well if we want. However, you may not choose to do that. Like in some cases, you will want to do that. So like, let's say if they're having a foot race where they win an item, we definitely want to have that on chain. But let's say they're just moving around the island, we may not care about it. And so you get to choose where you store the data. But I guess the first question we always get is, what about RNG? I'll pause here for a second because this is my son's favorite slide. He's 2, and of all the words he learned, Elmo was the quickest. I think he learned it within 5 minutes, and everything else was hours. So this is his slide. But yeah, so RNG fits pretty well into this. There's a bit more latency with it. We're using a service called derand. But the promise of like agreeing to a future random number is where we really get this, this going. And so let's take this example, but for shuffling a deck of cards. I want to shuffle a deck of cards. When I shuffle the deck of cards, I say, I'm going to shuffle a deck of cards between these states. This is my move, and this is the random number that I need. And you basically say, I need a random number after X time. Provided that time has sufficient time for transport, the other game clients can validate that and get the random number from derand, which we know can be unknown at the time there. It also allows us to replay it, so when you replay it all, the numbers will be the same. So really cool model, and like derand are doing an awesome job there. I would encourage digging into that. Obviously there are some like issues with random number generation. Not everyone can control the nodes, but they have a pretty good setup there, and we've been using them for our VRF and been very, very happy with it. Finally, I want to show you guys a kind of sneak peek. Let's see if this works. Of how it looks. So this is our kind of work in progress combat system. Again, super alpha here. Like we made, like all these are placeholders. This is stuff we're still playing around with. But this is using this kind of peer-to-peer validation thing.
So it's not local, right?
So this example is local, but just because live demo network in a room, definitely not going to do the actual peer-to-peer validation here. It's just set to my own. But these moves are in the deterministic way that would be applicable to do with peers. And so in this example, I'll play some cards. I'll deal some damage. I think I don't have enough to do it. No, I do. I may have enough for that. So these are skiffs. Again, this is all prototype kind of stuff. So these are card-based. We're playing around with some ideas with cards. Nothing that is final yet. But the idea here is each of these kind of things is going to be a move. We can end turns and things like that. But where this really gets interesting is we have this kind of debug thing on the right-hand side here. And this is actually a little tool that allows us to play. So you can see here we've got 10 moves that have happened in the game. Obviously this can be thousands of moves, but because we will wrap these up and then store them on chain, if you want to observe a game and see if someone was cheating, you can go in, you can rewind the game to the point, and you can watch everyone's game. So using that deterministic ability to be able to see, inspect, and really get that, I mean, hate to be super punny, but I'm a dad now, like proof of play of what we're talking about with the thing. So it's a bit of a demo. Just wanted to show you guys where we're heading. I'm going to be talking to people at happy hour about this idea, see what people have ideas on it. And yeah, that's a bit about us. Let me tab back. Yeah, so a couple of things, contact details here for our Twitter. I'm Matt. I'd love to stay in touch with more people around here. And thanks.